Hello, welcome to Adeept tutorial. Today we'll introduce you the follow-up and light follow function of the Starry bit. First, what is to follow? Let me show you. In fact, the principle of it is similar to the obstacle avoidance we talked in the last tutorial. It also applies the same infrared-based obstacle avoidance sensor. So now let's have a look at the code of car following. Open Google Chrome, make code, and then directly open the code of follow. You can click import here to import your code. You may know how this number comes from if you watched our last tutorial. The code is actually very simple, which is by reading the value of infrared obstacle avoidance sensor to determine. Look at the values of these three ranges. Here, when the value of IR is less than 150, the motors retreat at a speed of 200. 1 means backward. When it's between 150 to 500, the motors move forward at a speed of 300. When it's greater than 500, the motors will stop directly, and that makes the car can follow. Click Download to download the code to Microbit. And I have already downloaded before. Now we demonstrate again. Okay, let's change to Python. Open the code, and you know that this is the same as main code. You can take a glance and slightly compare. Download it to Microbit. As easy as you know, so I won't demonstrate here. Next, we come to the light follow. To use this function, you need an additional illuminating device, preferably a flashlight, which can be concentrated. Light follow, as the name suggests, following the light. As you can see, here is integrated with two photo sensors. When shine the flashlight in this way, the car goes in this way. When shine that way, the car goes in that way. Now check the schematic diagram. This is the schematic of the photosensor. The circuit here is two photosensors connected in series. In this case, they will have a value directly when they are energized. We use a flashlight to shine any of these two photosensors. The value will change. And it is connected to the pin 1. We can see up here. And this is the Microbit pin 2. Okay, now we check out the code. Click this followed light. And next we give you a little explanation. Here is the control ports and the number of the RGB LEDs in the light follow mode. Why we choose 6 LEDs? Because the 6 LEDs are at the bottom of the car. We can't let all the LEDs on the top light up. It will affect the reading of the photosensors. Then set the color of the 6 LEDs to the rainbow. Set the control port of photosensor to pin 2, and then use a judgment statement. When the value of the photosensor is less than or equal to 400, the motor moves forward at this speed. And when the value is greater than or equal to 750, the motor moves forward at this speed. If no light is detected, it goes straight. Now download the code directly to the Microbit. Unplug the USB cable, prepare a flashlight, and switch on the Starry bit. Shine in that way, it goes in that way. Shine in this way, it turns to this way. Then you see the new Python code. Click Load Import the code. Also, we need the Microbit head file, a NeoPixel library, and then set the control port and the number of LEDs. Here, just need to define one green LED. You can define the color as you want. Define the color of the controlled LEDs. Program of control the motor. Define the program of light follow. We make all the LEDs display green in the running process. And then read the analog value of pin 2. Here, to determine the values read by photosensors, it is the same as the setting here. And then let the motors drive. Execute the code of light follow directly in the loop. Finally, download the code to Microbit and you can see the effect. Okay, this is pretty much it for this time. I'm sure you already know the program of follow-up and light follow. In the next tutorial, we will introduce the live fighting of Starry bit. If you still have any questions, post to our forum. We will reply to you soon. See you next time.